Hello and welcome to episode 63, an interview episode of the Primary Maths Podcast, the show where we talk all things primary maths with me, Jon Cribwell. I have to apologise, listeners. I am struggling a little bit with a spring cold, so if I sound a little more husky than usual, I apologise, but hopefully my voice will hold up through this interview. It's a fantastic interview this week. We are focusing on times tables. Now, don't worry if you're not in year 4. This isn't all about the multiplication check. We're thinking particularly about how children learn their times tables and what cognitive science and psychology tells us about how that process works, about the barriers and the enablers that children face, and what we can do as teachers to support our pupils in learning their times tables so that they are able to apply that knowledge and not just recall facts quickly, but also have a deeper understanding of the structure of multiplication. So all of that is coming up. In the meantime, if you wouldn't mind just hitting the subscribe button to this podcast on whichever platform you're listening to, that will make sure that you never miss an episode. And if I could ask another favour, a quick review, even if it's just a star rating, makes all the difference to us as well. So without further ado, let's get on with today's interview. My guest today is Professor Lucy Cragg, and I am delighted to have her on the show. Welcome, Lucy.
Hi, Jon. It's lovely to be here. Thanks for the invite.
No, absolute pleasure. Thank you for giving up your time to come and talk to us about cognitive science and multiplication, I think, in particular, is what we're going to talk about. But would it be okay just to start by introducing yourself? You are working at the University of Nottingham at the moment, I believe. How did you end up where you are, Lucy, if that's all right?
Yeah, no, that's fine. So, I'm a professor of developmental psychology in the School of Psychology at Nottingham. I did my PhD on executive functions in children, which are the skills that allow us to control and guide our attention and behaviour. And while I was doing my PhD, I met Camilla Gilmore, who was doing her PhD in mathematical cognition at the time. And people were just starting to get interested in how executive functions might help with learning maths. So we decided that we would kind of combine forces and look at this together, because previously it had either been done by people who knew loads about maths but not very much about executive function, or it had been done by people who knew loads about executive function and not very much about maths. So we thought that by combining forces, we could kind of put those two things together. And so we've been working together for the last, probably about 15 years or so, looking at, first of all, how executive function is involved in arithmetic more generally, and then recently we've just finished a project looking at specifically the role of executive function in learning times tables.
Fantastic. And can we, excuse me, my voice, as you might hear, is on its kind of last legs. Can we just clarify what we mean by executive function? Is that sort of the well, you'd be better placed to explain it than I would, I think, Lucy. What is executive function exactly?
So there are lots of different definitions of it, but the definition that I like to use is the skills that help us control and guide our thoughts and actions. And it's kind of an umbrella term for various different processes. So it's things like being able to hold the goal of what you're doing in mind, being able to kind of manipulate information in your head. That's often termed working memory. And then it covers things like being able to ignore distractions or suppress kind of unwanted responses. That's termed as inhibitory control, or being able to flexibly switch your attention between different things or respond to different things in different ways depending on the situation. And that's sometimes termed cognitive flexibility.
And you use the term skills there. So are these innate abilities, or are they things that can be improved and worked upon and learnt?
So a bit of both, really. There's a bit of nature and a bit of nurture there. So the very first signs of executive function emerge quite early on in infancy. A few months of age, children become able to hold something in mind when it's not there in the real world, and to start to kind of control their actions. And then it does improve. It improves a huge amount between the ages of 3 and 4, so just before children start school. But we also know that environment can have an impact, and particularly we see that when children start school, their working memory really improves, I think, because they're having to use it a lot more while you're there. So yeah, it can. there is an environmental influence. You can improve your executive function. What doesn't seem to happen is that doesn't automatically, we know what executive function is really important for learning, but just by training your executive functions, that doesn't necessarily then transfer to kind of better performance in the classroom. But it is influenced by environmental factors, definitely.
Okay, fascinating. It's not something I've looked into an enormous amount before, but you mentioned that you are a professor of psychology. Is that right?
Yeah, that's right. Yeah.
Yeah, but so I'm really interested in how you came to look at things from a maths through a maths lens, particularly. Was maths something that you enjoyed at school? Was it a subject that you engaged well with, or not?
Yeah, I always really enjoyed maths at school. I used to, yeah, just I found it really interesting. I'd love just the problem solving approach of it. Yeah, kind of.
Can you remember much about maths at primary school, particularly, Lucy?
Um, a little bit. I remember we used to have these workbooks, and we used to work through our little workbooks, and then we'd finish that one, and then we'd get the next one, and we kind of work with that. Is my main memory of it, I
Yeah.
think. Mm.
I'm always interested to hear what people recall about primary school maths, because I just think that it's changed so much over the years. And regular listeners will know that I don't recall being taught an awful lot of maths at school. There was a lot of working through things independently, as you sort of
Yeah.
alluded to a little bit yourself there, and less sort of direct instruction, I think. So yeah, I'm just sort of collecting recollections of that as we go along. So maths was obviously something that you enjoyed. Did that then influence you when you came to looking at areas of research?
Yes, I think so. I think because particularly as well. So I come from a family of teachers, and my mum was a Senko, and she was helping support children, particularly with reading difficulties. And we know so much about kind of the science and the psychology of reading, but really, when we first started out, there was just so little about how children learn maths, and so Camille and I were both really interested to say, well, if psychology is involved in reading, surely it must be involved in learning maths as well.
So that's obviously something that we're really interested in as well. Is what can psychology tell us about how children learn maths? You mentioned links with reading before. Why do you think reading was taken as a particular? I mean, there may not be an answer to this, Lucy. I'm just curious. Why do you think there was particular interest in how we learn to read initially from a psychological point of view
So I
or
think,
psychology point of view? Are they different things? I'm sorry,
yeah,
not my
so
area of expertise.
there's always been there's always been a lot of research into language and reading in adulthood. So we know an awful lot about how kind of words and everything to do with kind of language is represented in the brain. Um, and um, and that kind of then spilled down into understanding how it developed. There's still relatively little kind of comparatively about maths, and I really, I'm not sure. You tend to get in research, often you'll get a kind of, a few people start researching a topic, so then kind of lots more people are drawn to it and develops big areas. But you kind of think there should be, sometimes you'll go to the literature and think, oh, somebody must have looked at this, this is a really important question. And actually, there isn't for some reason. So, yeah.
Yeah, it'd be interesting to find out. Just from my own point of view, I'm just wondering whether people's backgrounds, experience of maths at school, whether that influences what they go on to research later, and thinking about people's people who go into psychology, particularly whether there's some sort of overlap or correlation there. I don't know, but that is really interesting. I'm really glad though that yourself and Camilla Gilmore are sort of flying the flag for this research, because it is fascinating and it's really interesting. And I think originally came across some of your work when I was looking at the multiplication tables check in year 4, and I think it's fascinating that it's spanning across two institutions as well, with Loughborough and Nottingham working together on this too. I read something around the multiplication tables check that you'd written, and I thought it would be great to speak to you and find out a little bit more as well, because times tables, particularly as somebody who found tables tricky to learn at school, and not because I I think my memory is okay. I can remember facts and dates. I did a law degree and had to remember lots of dates and case names and things in my degree. I know that I can remember those things, but I seem to really find it quite difficult to recall multiplication facts. And I certainly at primary school and secondary school didn't really understand the structure of multiplication. And so I was wondering whether there was a link between those two things, really, whether helping to understand the structure helps to recall facts. And I know that might be something that you've looked into. But um, if we start kind of at the start, what is it that cognitive science tells us about how we learn multiplication facts? And maybe how that might influence how we teach them as well.
Yeah, so, I mean, children learn their facts through kind of other multiplication practices. So, for example, work by Bob Siegler has shown that, if children are using procedural strategies, so repeated addition, for example, to work out a multiplication problem, then over time, the associations develop between those multiplicand and the product. So whatever it might be, 3 and 5 and 15, if they're kind of activated in your brain or repeated enough, then those connections develop. And so eventually you reach a stage where you see 3 and 5 and your brain automatically kind of activates 15 as well. So it can very much develop.
Is that why maybe some times tables are easier to recall than others because we see them more often? So doubles, for instance, we start with those quite early. So the 2 times table, we see instances of multiples of 2 very often, don't we? All the even numbers. And again, for me, for some reason, square numbers I seem to recall. So I knew 6 sixes were 36, and 5 times 5 was 25. I could recall those kind of landmark ones in my head. Is that just because I'd seen them more often, possibly?
So yeah, seeing them more often is definitely kind of one explanation and one theory. It's also to do with the strength of the connections and the way that the connections develop. And because in those tie problems, you've got 2 kind of the same, you've almost got a double yes. strength connection to the answer, if that makes sense, and fewer other competing answers. So we talk about neighbours, times tables neighbours, so the kind of number of other facts that a fact is connected to. And actually, the fewer neighbours an item has, often the easier it is to remember, because there's less competition when you're trying to recall the answer to, say, 3 times 5, your brain will also activate the answer to 3 times 4 because there's a connection from 3 to 12, and 4 and 20 because there's a connection from those numbers to 20. And your brain is kind of, it's like a race almost, and then your brain chooses the one that kind of reaches the finish line first. So the fewer sums that there are in that race, the easier it is to recall the correct answer.
Yeah, that's interesting. So is that also why sometimes, or could it also be why sometimes, and I'm really conscious when I'm talking here that I know that we're talking about things that have so many different potential contributory factors to that it's very hard to say, yes, this is definitely why this is happening or not. But so if sort of take that as read, I think, for this conversation, otherwise I'm going to be second guessing myself all the time. But certain facts, sometimes we get stuck in our head that are incorrect as well, and it can be quite hard to unpick those as well. So for a while I had, having said that square numbers were a strength, I for some reason had 7 times 7 was 42 in my head for quite a while, and I had to really think about that to unpick that as to why that wasn't correct. So is that the same thing then? Can we overlearn or potentially make a stronger connection about a fact that is correct as well? And
yeah, it's really interesting that you said that it was 42, because we find that kind of, particularly for children, 70 or 80% of the errors that they make are these neighbouring problems. So obviously it's 6 times 7 because of the way that they're connected. And you develop these connections through associating with them. So if you keep activating the incorrect answer, then that's going to have a stronger connection. It's going to kind of be stronger in the race than the correct one. So yeah, that can be why errors kind of tend to persevere, which is why it's helpful to, and you can see how it happens with repeated addition. You just got to make one step wrong in the repeated addition and you get to 42 instead of 49. And then
so that's really interesting. So a lot of the games that we can, without naming any particular brands, but a lot of the games that we give pupils to practice times tables, and I'll say that in my opinion that is just practice most of the time, because there's not a lot of actual teaching going on there. But often if you input the wrong number, it will tell you the correct number briefly and then move on. And so I'm just wondering whether a better approach would be for the pupil to actually correct that at that time, rather than just seeing the incorrect number and then moving on. Because when I wasn't brilliant on my times tables all the way up to teaching them, Lucy, and one of my sort of trauma memories that I've got is of being the maths lead and having to do a times table race against another pupil in front of the whole school in the front of the hall, and everybody could see all the answers that we're putting up on the screen, and being frustrated when when I inputted a wrong answer, but not necessarily really paying attention to what that answer was, because I knew that it would reset in a moment and I'd be thinking about another one. So just thinking about teaching wise, then I wonder whether, in terms of strengthening that connection, it's worth actually correcting it at that moment rather than just seeing it and moving on. Our attention maybe moves on quickly. I don't know.
Yeah, there might be some. I'm just trying to think of the kind of, because it's turned into the feedback literature, which I'm less familiar with. I think that, yes, correcting it with the correct response would be important. Whether it matters, whether that's immediately after, I think a lot of these programs do kind of oversample on those problems that children are struggling with. So they will then see that and have the opportunity to put it in or correct.
Yeah.
I think getting some feedback is more important. So as long as they are at some point correcting it, which I think is built into these programs.
Yes. Yeah. As you say, it will probably give them the chance to have another go at that question sooner rather than later. Yeah. Yeah, that's a good point.
Yeah, we could do a whole other podcast on kind of error awareness and those kind of things. That's
I just think it's fascinating because we'll get on to what the multiplication check tells us soon. So you've mentioned a couple of things that are important already. So things such as building connections between the numbers and seeing them regularly, and different ways to do that. So in terms of teaching that, I'm guessing seeing it in different contexts would be important as well. So yes, chanting them, that might begin to build a connection, but also seeing different representations of those structures, would that be another way that we might begin to build those connections, those sort of mental connections between the numbers?
Yeah, so we did a project recently, primarily looking at different ways of practicing times tables, but I think it speaks to this as well. And actually, it doesn't really matter what you're doing as long as you're kind of building those associations. But I guess the important thing is, like you said, you learned the timetables, but you didn't really understand the structure of multiplication. It can be very easy to just learn the facts. We can easily learn to associate 3 things together rather than 3 and 5 and 15. It could be, star times circle equals square or whatever. You could repeat those and you could learn those relationships. But if you want to also develop that understanding of multiplication more generally, then using strategies, either procedural strategies like repeat addition, or using representation, so you're kind of linking those numbers to the quantities and arrays and those kind of things, then you're not just developing, the facts just based on the written numbers, but you are also building that deeper understanding of multiplication as well. And the facts just arise from that naturally. If you teach that and you're making those associations, then eventually you will be able to store and recall those facts.
I'm conscious of not trying to jump around this conversation so much because there's so much in my head that I want to talk to you about, Lucy, but I think it's probably pertinent at this point just to say, given that you've mentioned that recall of facts is different from understanding the structure of the maths, we know that the numbers of pupils who have answered over the last few years, the numbers of correct answers in the multiplication tables check has increased year on year. So it seems that whatever teachers are doing in school is enabling more pupils to answer those quick recall. We know that the multiplications check, for anybody perhaps listening outside of England, this is a check that's given in year 4, so when pupils are about 8 or 9 years old, and they have 20 questions or 25 questions and 6 seconds to answer each one, and it's purely kind of an algorithm. It will say 6 times 7. Pupil has to enter 42 on a computer or a tablet, and then that's either correct or incorrect, and it moves on. So the numbers of pupils that have been, this average score has been increasing year on year for the last few years since that was introduced. However, I think I'm right in saying what we're not necessarily seeing in year 6 then, 2 years later, when the end of Key Stage 2 tests are administered, is an increase in the numbers of pupils who are successfully solving problems with multiplication, or being able to answer more complex problems that involve multiplication. That hasn't necessarily fed through yet. Now, whether it will do, we need to wait and see. But could that speak to what you are talking about there, Lucy, which is there may be a difference between just knowing 6 times 7 is 42 and understanding what 6 lots of 7 are and what 7 lots of 6 are and what that might look like and how we might use that, and related facts as well?
Yeah, definitely. So in our study that we just mentioned, so we gave children 2 weeks of training of practice learning new times tables. So we kind of split the children into 3 groups. So they were learning times tables that were kind of just above the level that they were at. So we taught them 10 new tables. And before that, before and after, we gave them 2 different types of tests. So we gave them a multiplication fluency task. So that just had all the times tables on from 1 to 12, and they had to answer as many of those as they could in 5 minutes. So it was, just, as you said, just written sums that they had to do. But then we also gave them an applied multiplication test. So these were the kind of questions that you would get in a more general math test. So it was things like being able to represent sets, word problems, questions about whether numbers were in sequences. So all sorts of different applied questions. And what we found was that the children improved on the fluency test, so they were better at recalling these the answers to these sums. But we found I think on average, children improved by about 4 items over the 2 weeks. But on the applied task, they only improved by kind of 1 item. And when we were looking at individual children, even children who'd scored really highly on the fluency task weren't scoring that highly on this applied task. So definitely just being able to recall a multiplication fact doesn't mean that then you can use and apply that in a more complex or real world situation. So we think there's definitely more that needs to be done to support that link.
And I guess that there might be multiple reasons for that, mightn't there? Because we know that problem solving generally is cognitively demanding and requires different skills from just being able to recall your times tables, even if multiplication is a factor in the problem solving. But I think it's definitely something for teachers to bear in mind, that yes, knowing the facts is helpful because it can reduce that cognitive load in terms of, if I've got to calculate every time 6 times 7 to know that that's 42, that's an extra step I've got to do, isn't it? An extra step I've got to take. So there's definitely a purpose to knowing and a benefit to knowing your times tables. But I guess what you're suggesting is that it isn't necessarily the be-all and end-all in order to be a successful mathematician in terms of being able to apply that and solve problems using it.
Yeah, I mean, I guess it would be very easy to think, we just teach children their times tables and then, that'll open all these doors to the next level of maths, as it were. But unfortunately, it's not that simple, which, yes, is always the case. But, transfer is hard, and you have to give those examples and scaffolding to show children how to use their knowledge.
I'm not sure whether you looked at this particularly in your research, but were pupils who scored lower on the fluency test, did they generally score lower anyway on the reasoning or the applied maths test? Was there sort of a relationship between that?
Yes, there was. So we found a relatively kind of strong relationship in the sense that children who score poorly on a fluency task will also score poorly on an applied task. But there is all sorts of reasons. We didn't take lots of background measures. So, generally across the board, you find if children struggle in, one area or type of thing, then they will also struggle in something else. And we didn't control for things like, overall ability or those kind of things, or language skills, or all of those things that could contribute to those things as well. So, but I think it's the interesting bit is that even when you improve one of those skills, the amount of improvement in the fluency task doesn't relate to the amount of improvement in the applied task, even though overall, if you're better at one, you're going to be better at the other.
I'm wondering whether there's something between, whether it's a delay thing, whether there is a benefit to learning those key facts and then beginning to unpick them, or whether there's any benefit to learning the facts through learning the structure. Did you look at that at all?
So we haven't looked at that explicitly, but I think that's a really interesting question. And I think we know that from general maths learning that, the procedures and concepts, or facts and concepts, kind of are interrelated and go hand in hand. So it's not a one or the other, and both can support each. So we know that just by doing the procedures or understanding the concepts, if you're associating those things, that's going to improve the fact learning. And knowing the facts does improve the applying it, because as you say, it reduces the cognitive resources so that then you can concentrate on the more difficult aspects of the problem. So I think it is, you need a bit of both. So I think both approaches would work. So I think what often happens at the minute is certainly the practicing of times tables is often can be very separated from your actual maths lessons. So it might be being done at home, or it might be being done, after the register fluency, for the first 5 minutes of the day or whatever. So it's potentially less clear to children, actually, this is relevant for the other stuff that I do in maths. It's not something completely separate. So I think there is benefit in kind of putting those two things together more, so it's clearer for everybody, how times tables can be used. But I think there may also be some benefit in, after children have got to a certain level of fluency with their maths, of then kind of showing how it's relevant, or working a bit more with the applied types of problems to link back to the times tables.
Yeah, it's really interesting. I think it's definitely something to bear in mind when we're teaching. I mean, obviously I saw this a lot as a teacher, but I've also got a daughter who is in year 3, and obviously her school has got an eye on next year, which is great already. And she's practicing using an app, practicing her times tables, and she tells me which ones she finds tricky, and she really wants to work on those. But she definitely sees them as a set of memorization tasks to do, and if I can just recall what these are, then I can pass the test. So again, not to sort of go over the point too often, but it really is how people see times tables, I think, as a result. I don't know whether that's fair to say that it's just as a result of the MTC, but I think it's definitely focused schools on learning those facts so that we can pass the MTC or take part in the MTC. But there's definitely a distinction between, the being able to retrieve them and being able to actually understand them. So that's really helpful. It's really helpful to think about it in those terms, Lucy. Thank you. Can we think about those children who find times tables disproportionately hard then for a moment? Because every teacher listening to this will have some children in their class who perhaps find additive structures relatively easy to work with, but for some reason, when it comes to learning their times tables, they just find those really hard and really difficult to understand. is it a case of just practicing more, or is there some evidence that something else might work better for those pupils?
So in terms of our direct evidence, so we don't see anything kind of qualitatively different about the children who are kind of at the bottom of the kind of the distribution of all the children that we look at. But we know with any area of maths, there are lots of skills that can kind of feed into why children struggle. So I think kind of getting a bit of a handle on why they might struggle can help. So, it could be, one reason could be, being pushed to do that speeded practice too early because they just haven't had enough time developing those connections. So, it might be a case of going back to the procedure, to the repeated addition. And eventually, if they do enough of that, then the facts will get there. It might, everyone learns at different rates. It might just be that they're kind of being pushed along and they just need to go back a step to get there.
Yeah, that's interesting, isn't it? Thinking about from a school's point of view, again, wanting to prepare and learn these facts quite early sort of makes sense because there's a lot of them to learn. But if we're introducing them before children actually understand what multiplication even is, then it reinforces that idea that it's just memorization. And there's a lot of children that will fail quite early, and that can have an impact on their self-esteem and how they think about maths generally, can't it? So that sort of makes sense, that being really strategic about when these things are introduced and at what point we're letting children fail repeatedly at recalling these facts.
Yeah. I'll come back to that in a minute, but another difficulty that children can have comes back to this idea of all those interrelated facts and the connections between them and the kind of race to choose the correct answer. And there's some research that was started by Alice Devisha looking at kind of children who really struggle to ignore distractions, and that it might be particularly that some children really struggle to deal with that competition between all the different facts. So, they might often say 42 instead of 49, for example, because they have difficulties with inhibitory control. So that process of selecting the relevant information and suppressing the irrelevant information. So that could be a reason as well. They might be fine on other areas of maths, but just because of that competition within the times tables, then they struggle with the fact recall. So that brings in the executive function side again that we were interested in.
Yeah, that inhibitory control. Inhibitory control, is that right?
Control, yeah.
Yeah, that's fascinating. So the idea of being able to focus and is that sort of direct attention towards one particular thing rather than and ignoring competing thoughts?
Yeah, and obviously that can play out at all different levels. It can be, ignoring distracting information in the classroom or your partner talking next to you, and it also applies to kind of things within maths. And some other research we've done suggests that it is the type of, there's various like subtly different types of inhibitory control, but it seems like the type of inhibitory control you need to resolve competition between these maths problems is the same type of inhibitory control that you would use, certainly that we tend to use in psychology tasks. So have you heard of something called the Stroop task? So where you've got to, you're given a coloured word, so you might be given the word red in green ink, and you've got to say green and ignore red.
Yeah.
So that type of inhibitory control seems to be the same types of skills are quite similar in that task as they are in kind of resolving this interference between the different times tables. So it could be that they have a general difficulty in ignoring kind of sources of information, and that contributes to their difficulties with times tables.
You said at the start of the conversation that executive functions are part nature, part nurture. So for those children that are finding this particularly tricky, some of that might just be part of their makeup and how their brain works, I suppose. But what things do you think we could try and do to help them to overcome those barriers that they might have?
So just an ideal solution might be, we'll just improve their executive function, their inhibitory control separately, and that'll transfer to maths. Unfortunately, that doesn't seem to work.
I was really hoping you were going to say that.
Yeah, there's a magic solution. Just do this programming, it'll help. Sadly not. And what we've actually found is that we thought originally that this inhibitory control might be particularly strong when you first learn, and then it might disappear later on as you kind of learn the facts, but actually that doesn't happen. Everybody experiences this, and it's because of the structure of maths, so you can't remove it. So some people have suggested, well, what we should do is we should remove that interference and just teach kind of isolated facts. So rather than teaching all of the threes, we might teach, this times table from the 7 times table, and this one from the 3s, and this one from the 5s, and then we won't have any interference, and that'll solve the problem for these children. A, that doesn't seem to be the case, and B, then you lose, as we've been talking about already, the facts become isolated and not kind of, you don't get that understanding of the structure of multiplication. So there are some things you could do that would improve their performance on the MTC, but I don't think they'd be helpful in the long term of supporting their maths development. So yeah, we would argue against that. One of the things in our study that we did that we were interested in was what happened when you practiced in a situation that kind of enhanced this interference. So we had 4 groups of children. 2 of those groups, we asked them to recall the answer. So like you would on lots of the standard practice apps. So it might say 3 times 5 and you have to enter 15 on the little keypad. But then we had 2 of our other conditions. They had 4 choices for you to choose from. So one of the answers might be 15, one might be 10, one might be 8 in case you, so we deliberately put in kind of teaser answers, foils.
That's what I wondered, whether they were random or was there some thought gone into it?
There was thought gone into them. So 2 of them were these kind of competing neighbours. One was the addition and one was a kind of closely matched number. And we thought that might kind of hinder children's learning because you were kind of creating this interference. But actually children learned just as well in those conditions as they did when they had to input the answer. So it doesn't seem that kind of learning with this interference has a problem.
What I really like about those, from a teacher's point of view, about those sorts of questions is it gives you the opportunity, if you've done it with the whole class or with a group or with an individual, however you're working, it gives you the opportunity to question, well, why isn't it this one? Why isn't it that one? And draw out that reasoning and the mathematical thinking. And I'm sure that helps children to consolidate those connections as well, in terms of, and also practice that skill of identifying which one it must be by process of elimination, if nothing else. More opportunities, I suppose, to strengthen connections.
Yeah. The other thing we found with that, going back to this point about if children get put off doing times tables because of the kind of speeded nature or they're kind of moved on too fast. Actually, it means that you don't, in fact, so 2 of the conditions were this choice, 2 were they had to input the answer, and of those, 1 of each they had to do under speeded conditions. They had to solve as many as they could in 2 minutes, and the other, there was no time pressure. And there was no difference. So overall, there was no difference in the amount of learning that occurred across those different conditions. But what we did find is that before we did this, we also asked children to complete a maths anxiety questionnaire, and the children that scored higher maths anxiety learnt less if they were in one of the speeded conditions. But actually, the other results showed that you don't have to do it speeded. You could learn just as much if you did it non-speeded. You could learn just as much if you did it by choosing the answer compared to inputting. And we found, this is only anecdotal, but we had one child who was in tears one day because she didn't want to do it. She's really struggled, and she'd been put in the speeded recall condition. And we were like, fine, do this one, do the unspeeded choice condition. No problem at all. She was more than happy to choose the correct answer, and that produces just as many learning benefits. So I think, there is no one way, that everybody has to do it. There's multiple different ways to get to the same outcome so that you can choose the one that fits the child.
Yeah. And I think kind of to sum up a lot of what we've said here, and it's really useful to have some evidence based to put this on, but it sort of also makes common sense as well, is that showing these things in lots of different ways, and with some thought to it, I don't mean randomly, but having a strategic approach to learning these facts and seeing the structure of them as well, and looking for opportunities to take away some of those potential sources of anxiety, such as the time nature of the test, certainly to start with. Again, just thinking to my daughter's experience, she was really frustrated because she only had a few seconds to think, or she was only giving herself a few seconds to think of it, because she already recognized that it was important to do this quickly. And sometimes I think that can really be a barrier to children, that they put themselves under more pressure, and that can cloud your thinking as well, can't it?
Yeah,
I know what I'm
definitely.
like sometimes in a time test. It's just added pressure. So taking away some of those, at least to start with, until we've built up some confidence, makes sense, doesn't it?
Yeah, definitely. And the speed does come. If you do it, then you'll get to the point where you can do that retrieval. You do the speed in the test situation, the speed is important, because without the speed, you don't know that you have actually retrieved it, as opposed
Yes.
to just calculated it. So the speed is important at the test. Speed is not important for the practice. I think that's the important
That's a
distinction.
really good takeaway. Yeah, that's a really good takeaway for teachers to think about and to use. Lucy, I realise we are taking up a lot of your time at the moment, but I'm really enjoying what we're talking
Talk
about.
about it for hours.
Yeah, I know, absolutely. And there's so much more that we could cover as well. Is there anything else that you wanted to sort of add to this particular little bit of the conversation before we wrap this up today?
I think we've covered the main things. Yeah.
Excellent.
The
Okay.
main bits of our research, yeah.
Yeah. I'm really sure that teachers will have found this very useful to hear, and maybe to think about from a different perspective as well. If they wanted to learn a little bit more about your work, and maybe the work that you've done with Camilla Gilmore as well, where's the best place for them to find out more about this?
So probably the best starting point is our website, which is sumproject.org.uk. And on there, so we've got a page all about the Times Tables project, and it's also got links to some infographics and some videos, some articles that are specifically aimed at teachers or a general audience. So we've got one in Impact and one in the Conversation, and we'll also put links on there to the academic papers that the research is based on. So we've got one coming out in a couple of weeks, and then the training study we're hopefully going to submit soon, so that should be out.
Fantastic. We'll put links to that into the show notes for this episode as well. So if you are looking for that website, you'll be able to find it. I've been on there as well. There's lots of useful things on there. So yeah, thanks. Thank you so much, Lucy.
We're always happy to hear from teachers as well. If people have got questions or follow-ups or want more information, then yeah, more than happy to drop us an email, and more than happy to help.
Fantastic. Thank you so much. And thank you so much for your time this morning as well. I know, as I say, the listeners will have taken heaps away from it. So I really do appreciate you giving up your time.
So it's always good to get the research kind of out there, and, and into to teachers who can, hopefully use it and, really make a difference.
Absolutely. I know we'll be coming back to these sorts of things before, so I'm sure this won't be the last time that I'm talking to you, Lucy. But again, thank you so much for your time. For the listeners, I hope you've enjoyed that. I hope you've found things to take away from it to use in your own practice or to support with colleagues. If you do have a colleague that you think would benefit from hearing this, please do share it with them. And as always, do drop us a like and a subscribe if you would like to hear more of this sort of content. Otherwise, myself and Becky will be back on Friday for another Aftermaths episode. And until then, I hope you have a good week. Thanks so much.